Hello everyone and welcome. So this video we're going to look at the solution for this morning's config challenge. So just to give you a quick refresh, our scenario is that we have a restaurant owner with a drying rack in the kitchen, and at the moment that drying rack just gets left on constantly by staff members because it's just on a normal switch. And so what they need the ability to have is for it to be automated. So during peak hours it will automatically turn on during those hours and turn off outside of those hours. But then they also need a manual input, a manual switch to turn it on for a period of half an hour should they ever have any extra functions on. So that's their need, their absolute requirement. They then also have a couple of extra things on their wish list. The first of those things is that they shut down on Christmas Day and Boxing Day. So they would like the ability during those 2 days for it not to run on the automated schedule. And then the second part of their wish list is they would like to know how much that thing is costing them when it runs, but they don't want to put an electricity meter or an energy monitor in. So let me switch my camera over to the demo case and switch my screen over to config, and let's get started looking through how to configure this. So now I'm on the mini server, so you can see that over there, and I will just change my screen to be on config. And as you can see, I've already got a plant config file ready for me, and I'm just going to connect into that mini server. There we go, and let's get started. So I think probably the most sensible way of starting this is to get that peak time out of the way, that schedule block where we want to say that between 1 p.m. and 3 p.m. and 7 p.m. and 10 p.m. turn on automatically. Easiest way to do that is just through a schedule block. So we can put a schedule block on the page, and in the schedule block we can tie in our peak times. So 1 p.m. through to 3. And we probably want that on every day. Oops. And so this is how we would do the schedule period. So there's 1 p.m. to 3 p.m. and then we would need the same for 7 p.m. until 10 p.m. So again, just do that there, and you'll see when you've dragged it out, you can actually manually edit it from here as well. So 7 till 10. Hold down Control allows you to copy and paste. And there we go. That's our schedule times. And because this schedule block is set as digital, it means that when it's green, it will output a 1. When it's not green, it'll output a 0, on or off. Perfect. So that is the peak times sorted. The next part of the scenario is having a manual input that they can press that will activate it for exactly 30 minutes. Now, there are several ways of doing this. So straight off the top of my head, I can think that you can do it with a retractive switch because you can set an output duration on a retractive switch. You could also use a switch off delay because once it gets a pulse on the trigger, it switches off after an adjustable delay. You could use a delayed pulse with a 0-second delay and then again setting the output duration. I personally am quite a big fan of the stairwell light switch, just because it looks really nice in the app. So I would use that as my option. And on the stairwell light switch, I need to set my parameters. So I need to set my duration for on, which for 30 minutes, if my maths is correct, is 1800 seconds. I don't care about a switch off warning time, and I don't care about a duration of the switch off warning. I only care about the duration that it's on for. And I would then need to have my manual input, whatever it was in the actual kitchen area, let's say a push button. So that is going to be our manual override. And that manual override would trigger the stairwell light switch. So that is the 30-minute manual trigger and the peak time schedule sorted. And then all I would need tied into those two things is the output for the dryer itself. And then both the schedule and the stairwell light switch would both activate that dryer. That is the entirety of the first part of our scenario done. So the need of the customer sorted with those two blocks. If I shove that into simulation so that you can see, you'll see that at the moment they're both currently off. That's because at my time, at the time that this webinar is running, it is just after 5 p.m. So I am outside of these two time periods. I'm in the middle here, so it's off. If I press this manual override, you can see that the dryer now comes on, and it will be on for 30 minutes until that stairwell light switch goes back off. So brilliant. So now let's get over to the customer's wants. Now, the first thing that they want is they want the ability to not have it automated on this schedule on Christmas Day or Boxing Day because they're not open. The simplest and easiest way of doing this is over here on the left-hand side in the periphery list, you've got operating times. And there's a bunch of default operating times. We can actually pull in all of the UK's operating times if we wanted to, or we can create a new entry. And we can create a new entry, call it Christmas. It happens every year on the 25th of December. So that one can be Christmas Day. And then we also want one for Boxing Day. And that happens on the 26th of December every year. So now that we've got those two operating times, you'll see on an operating time, you can assign an operating mode to it. So what this will mean is that during that day, that operating mode will be active, which is public holiday. So I just need to make sure that when it's in public holiday mode, on the schedule, there is no activation. And that means that on the 25th and the 26th, this schedule block will switch to public holiday because that's what I've put in these operating times. And because there's no active time during that period, it won't be on. And again, we can see this in simulation because in simulation, I can go to a specific day. So if I do that during our period of time that we want to normally run it, you can see it's off. So we're inside of that 1 p.m. to 3 p.m., but because it's Christmas Day, the dryer is not active. Wonderful. So that's the first part of the customer's desired list. Now, the second part of the customer's desired list is they would like to know how much this is going to cost them, but they don't want an electricity meter or an energy meter installed. So what do we know? We know that this will draw 2 kilowatts of power when it is active. We also, because we're the only thing controlling this dryer, we're also going to know how long this is actually on for. So we can take those two pieces of data and that gives us our kilowatt hours. And the way that we can do that is, firstly, we need a block that can count how long something has been active for. And there's actually a block purpose-built for this called the utility meter. On the utility meter, you put pulses into TR, which is the trigger, and it counts those pulses, and when it hits a certain number of pulses, it recognizes it as 1 kilowatt hour. That's where we'd put a normal electricity meter into, but we can still use it. And what we can do instead is we can actually use a pulse generator tied into TR here, and we need to invert the input of the pulse generator so that it needs to be activated by either our schedule or by our stairwell light switch. So when either of those goes on, it activates the pulse generator, and the pulse generator outputs a 1 second on and then a 1 second off. So what this means is that this pulse generator, if that dryer was on for an entire hour, would give us 1,800 pulses in 1 hour to our utility meter. Now, Because our utility meter, we want to know the actual kilowatt hours, and we know that this is 2 kilowatts. If this dryer was on for 1 hour, it would actually be 2 kilowatt hours. So that 1800 pulses per hour, in the utility meter, we actually need to say that 900 pulses equals 1 kilowatt hour. So that way, when that pulse generator gives us 1800 pulses for 1 hour, it means that the utility meter recognizes that as 2 kilowatt hours. And that's how we solve the energy problem, how we monitor how much this is using. And then the final part is the actual cost. So how much does this really cost? Well, again, like with everything in Loxon, there are a few ways of doing this. One of the simplest ways would be a block called virtual state. And a virtual state doesn't really have any other purpose than to display something in the app for you. So if I tied AQ directly into the virtual state block, it would literally tell me how many kilowatt hours it's using. But I want to know that as a value of cost. So if I know kilowatt hours and I know how much my electricity company charges me per unit, so per kilowatt hour, I can do a nice and easy formula. So I could have a formula block with that output there into the formula block. And in the formula block, if I double click it, I can say that input 1 is my kilowatt hours. So I want to multiply that by my cost per unit. So let's say our cost per unit is 15p. Now that's brilliant. But what that will give us is the cost on AQ out in pence. Now we want that cost in pounds and pence. So what we would do is we would say that it needs to do the calculation first for AI1 times 15, and then we divide that by 100 to give us a value in pounds. We then tie that into the virtual state. And in fact, I'm actually going to move this down just so that everything fits on the one page and do that with a reference instead. And that will feed into our virtual state. Now, the other nice thing about a virtual state block is on the display, we can say to how many decimal places it displays the value, and we can also put a symbol before the value as well. So we could put a pound symbol. And then if we save all of that in, that is the entire scenario done. So schedule block for those peak times, stairwell light switch for the manual override. Then for the extra little bits and pieces, we create operating times for Boxing Day and Christmas Day that trigger a specific operating mode. During that operating mode period, it doesn't activate. And then we want to take the length of time that the output is on for through a pulse generator into a utility meter that is recognizing the number of pulses and therefore how many kilowatt hours. And if I stick that in live view, you can see at the moment nothing is running because, as I said, we're outside of our normal time period. But if I trigger input 1 in my demo case, our dryer now activates, and that's going to activate for half an hour. And as you can see, the pulse generator has already started sending pulses to the utility meter. The utility meter has already started going into the formula block, which has already started feeding into the virtual state block. Brilliant. If we give that a little bit of time to run so that we can actually have something relevant on the end of it, I can also show you the web interface. So the app essentially. And in here, you can see I've already put it in the kitchen. Here's our stairwell light switch. As I said, the nice thing about this block is it gives us something nice to visualize in the app. So I can already see that it's got 29 minutes and 11 seconds left of runtime. I can also see that my schedule is currently disabled because I'm outside of the time period. I can see my utility meter, and that tells me that currently I've used 36.7 watt hours, and as we can see, that's currently counting up, and that's feeding into my virtual state block with the amount of money that that is actually costing me. And there we have it, all solved. Wonderful. I hope you enjoyed that. Please join me again for the next one. Otherwise, see you again soon. Thank you.